Okay, so our next video is on geometric sequences. So we're back thinking about sequences, which hopefully you remember means a list. And we have terms that are separated by commas. And this time, instead of being arithmetic, it's geometric, and we'll see what that means. So let's look at this first sequence right here. So I start at -5, and I go to +10, and then -20, and then +40, and then -80. So how are these terms related? What happens as I go from one to the next? And hopefully you can see that I'm multiplying by -2. So you can see that sign change from term to term. So I know I'm multiplying by -2, and that is called the common ratio. So for example, if I take this term and divide it by the one before it, I get -2. Or if I do that with these two terms, for example, -20 divided by 10, I also get -2. That is called the common ratio, and we use the letter R for that one. So have a look at this one. What do you think the common ratio is there? How are they related? I hope you saw that 6 divided by 2 is 3, and 18 divided by 6 is also 3. So in this one, the ratio is 3. So here's a formula for you to write down and keep in your notes. It would be on our formula sheet as well. And the nth term, so this is the term in position n. This is the first term, term 1. And R is the common ratio. Oops. And then it's to the power, there's an exponent, n is the term position, n minus 1. So let's look at this problem here and just practice using that formula up there. So 6, 30, 150. I'm going to take 30, I'm going to divide it by 6, and that gives me 5. Or alternatively, I could have taken 150, divided that by 30, and that would also given me 5. So the common ratio R is 5. The general term means when I write Tn equals the first term, which is 6, times 5 to the power n minus 1. Now please do not write this as 30 to the n minus 1. Remember, in BEDMAS, the order of operations, I have to do exponents first, then multiplication. So this is not equal to 30 to the n minus 1. That's a common mistake. Please try and avoid that. What is the sixth term? So term 6 would be 6 times 5 to the power 6 minus 1, which is 6 times 5 to the 5th. So I'm going to take out my calculator and do that, and I get 18,750. And that is term 6. And now, what position is 93,750 in? So 93,750 is 6 times 5 to the power n minus 1. So what I'm going to do is start off by dividing both sides by 6, and I get 15,625 is 5 to the n minus 1 after I divide by 6. And now what I'm going to do is take out my calculator and sort of guess and check and go, what's the power of 5 that equals 15,625? And so if I do that, I get 5 to the power 6 equals 5 to the n minus 1. So 6 is n minus 1. At this point, I'm equating these exponents. And so n must be 7. So this was the 7th term. What position is 93,750 in? It's the 7th term. All right, let's look at a couple more problems down here. And I'm just going to clean this up so I have some more space to work with. All right, our problem down here says, determine the number of terms in 7, 21, 63, and 15,309. So basically we're saying, what position is this in? So you might want to try this. What do you remember what you know from arithmetic and how you find the position number and so on? And then I can show you. So what I would do first is divide two consecutive terms, say 63 divided by 21, that's 3, so that's r. Term 1 is 7, so I could start off by writing the general term. Tn is 7 times 3 to the n minus 1. And I want to figure out what position this is in. I want to know n. So 15,309 is 7 times 3 to the n minus 1. It's very similar to what we did here. So I'm going to divide both sides by 7. And I'm going to get 3 to the n minus 1 is this number divided by 7, those cancel. I wrote that down. It is 2,187. And now I'm going to do the same thing. 3 to what power is the same as this number? And that turns out to be 3 to the power 7. So n minus 1 is 7, so n must be 8. So how many terms are in this sequence? There are 8 terms. Down here we have another kind of fun problem. Determine the first term and the general term for the sequence knowing these things. Term 3, so I don't know term 1, I don't know term 2, but this is 54. I don't know term 4 or 5, but this, term 6, is negative 1,458. So I want to find the general term and the first term. So what I might do is use my formula. The nth term is term 1 times the common ratio to n minus 1. So 54 is term 3. So it's going to be term 1 times r to the 3 minus 1. Or if I want to make that simpler, r to the power 2. And that's kind of like my first equation. And unfortunately, I have 2 unknowns, so I can't really solve this yet. But what I'm going to do is the same with term 6. So term 6, which is negative 1458, is term 1 times r to the power 6 minus 1, which is 5. So I'm just going to put that down here. And now I have 2 equations that I can work with. And what I want to do actually is divide these. So I'm going to divide over here 54 term 1 r squared. And if I divide these, negative 1458 divided by 54 turns out to be negative 27. Term 1 over term 1 cancels. And remember, when I divide powers, I subtract them. So that's r to the power 3. And I'm just going to take the cube root of each side. So r is negative 3. And now if I go back to, say, this equation, term 1 times negative 3 squared, term 1 times 9 is 54, divide by 9, term 1 is 6. So over here I have 6, and each time I'm multiplying by negative 3. So I could fill in the rest of this if I want. It asked me for the first term, well, that's 6, and the general term, Tn, is going to be 6 times negative 3 to the n minus 1. And there you have it.